cosmic lightning strike, a gamma ray burst, could turn our entire world into ash in the blink of an eye, with enough energy to vaporize planets and wipe out all life, as if we were nothing more than a flickering flame in the vast darkness. Humanity has stared into the void, unaware that lurking in the depths of space, lethal phenomena are silently waiting, ready to unleash destruction that defies our understanding of a universe's true power. If the next gamma ray burst hits, it could erase us instantly, leaving only echoes of what once was. So, why are we still vulnerable? What do we stand to lose, and how close are we to witnessing a cosmic catastrophe that could end everything in a heartbeat? Stay tuned. This isn't just science fiction. It's a terrifying possibility lurking right beyond the edge of our perception. The power of gamma ray bursts. A gamma ray burst packs a force so immense that it challenges the very fabric of cosmic stability. When a dying star collapses into a black hole or neutron star, it unleashes a jet of gamma rays, high-energy photons traveling at nearly the speed of light that can span thousands of light years. These jets pierce through space with an intensity that is almost incomprehensible, equivalent to the energy our sun emits over several billion years, concentrated in just a few seconds. The true threat lies in the devastating reach of these bursts. When directed toward Earth, a gamma ray burst could strip away the ozone layer within moments, unleashing a cocktail of ultraviolet radiation that would devastate all surface life. It's not just the immediate blast that's terrifying. The aftereffects could linger for years, disrupting climate systems and wiping out crops globally. The sheer concentrated power of gamma rays can cause molecular destruction in the atmosphere and even directly damage DNA, which makes the entire biosphere vulnerable to extinction in a blink. What makes gamma ray bursts even more formidable is their ability to be entirely unpredictable and extraordinarily distant, yet still lethal. Sometimes, the burst originates from galaxies millions or billions of light years away. When the beam of gamma rays hits Earth, the energy flux can be comparable to detonating 1 trillion atomic bombs instantaneously. The mere possibility of a burst pointed in our direction leads scientists to monitor the skies relentlessly, knowing that the universe's most violent phenomena can happen at any moment, with little or no warning. On a cosmic scale, a gamma ray burst is like a divine laser, capable of vaporizing planets in the blink of an eye if aimed directly at us. The odds of such an event occurring nearby are incredibly low, but not zero. The potential for sudden destruction is a stark reminder of how fragile life can be amidst the vast, indifferent universe. It's over in seconds, an annihilation event that would leave nothing but cosmic silence. As far as cosmic threats go, gamma ray bursts are the ultimate embodiment of how the universe's raw power can rewrite the fate of worlds in the thinnest of moments. The cosmic distance scale. The universe is an intricate chessboard, with each piece separated across staggering distances that boggle the mind. The cosmic distance scale functions as humanity's way of measuring these miles. Thousands, millions, billions, and beyond, transforming cosmic chaos into manageable figures. When astronomers say a galaxy is 2.5 million light-years away, they're not just throwing out numbers. It means that any light we see from that galaxy left there over 2 million years ago, before humans even walked the Earth. This vast scale creates an illusion of safety. We're distant enough from most cosmic events that, in theory, they shouldn't impact us directly, right? But what if that profound distance becomes irrelevant in the face of an ultra-powerful gamma ray burst? Gamma ray bursts are among the universe's most violent acts, unleashing as much energy in seconds as our sun will in its entire lifespan. When these bursts originate within a few billion light years, they're already deadly enough, blinding flashes that can sterilize planets. But the cosmic distance scale begins to blur the line between safe and catastrophic. A burst originating in a galaxy 4 billion light-years away still takes 4 billion years to reach us. But once that beam is unleashed, no amount of distance can dilute its destructive power. The gamma-ray photons travel straight through space at the speed of light, slicing across cosmic voids, undeterred by the vast emptiness, unchanged by the scale that makes our universe so mesmerizingly vast. What truly adds an edge of terror is how the scale affects our understanding of danger. We think of light years as vast distances, forever distant and out of reach. Yet, the energy from a gamma-ray burst can compromise or annihilate life on Earth within moments once it arrives. The atmosphere might absorb some of the radiation, but a sufficiently intense burst could strip away the ozone layer, exposing the planet's surface to lethal ultraviolet radiation. It's like an insidious cosmic predator lurking behind the veil of distance, waiting to strike after eons of travel, its timing perfectly fitting the scale of the universe itself. And therein lies the paradox. The universe's vastness, which makes it seem safe, also holds within it the potential for instant devastation once the scale collapses in the blink of an eye during a gamma-ray burst path. The danger is compounded by the fact that we can't predict when and where these bursts will occur with precision. They originate from collapsing massive stars or neutron star mergers, events happening in distant galaxies. When one flares, its radiance bursts outward in a focused beam, like a cosmic laser, often pointed directly toward Earth accidentally or through chance alignment. The immense distances mean that the burst's initial energy disperses over space, but when directed straight at us, that beam can concentrate into a lethal dose of gamma rays. On a cosmic scale, the distances are enormous. Yet within those seconds-long flashes, distance becomes irrelevant. The universe's scale might seem to insulate us, but the raw power of gamma-ray bursts can erase entire biospheres, rendering the universe's vastness a cruel illusion of safety. What is a gamma-ray burst? A gamma-ray burst is essentially the universe's most powerful and energetic flash of light, an explosion on a cosmic scale that defies human comprehension. These bursts are unimaginably intense, releasing in seconds what our sun will emit over its entire lifetime. Think of it as a concentrated beam of gamma radiation, emanating from distant galaxies, yet capable of transforming the fabric of life itself if it were directed straight at Earth. The origins of these bursts often trace back to cataclysmic events, such as the collapse of a massive star into a black hole or neutron star mergers. These violent cosmic cataclysms send shock waves through the universe, spewing out high-energy photons that race across the cosmos at the speed of light. What makes gamma-ray bursts particularly terrifying isn't just their raw power, but the fact that they are fleeting yet incredibly intense phenomena. They can last from a few milliseconds to several minutes. Yet during that brief window, they unleash the equivalent of thousands of times the energy of our entire planet. When the gamma-ray photons hit Earth's atmosphere, if one were struck directly, they could instantly strip away the ozone layer, destroy the delicate molecules that sustain life, and blanket the planet with lethal radiation. This is no gradual threat. It's an instantaneous cosmic killer, capable of obliterating Earth's biosphere in moments, leaving nothing but a barren shadow in the vast darkness. The danger lies in the unpredictable direction of these bursts. Gamma-ray bursts are highly directional, like cosmic laser beams aimed at oblivion. Despite their distant origin, often billions of light years away, their immense energy means even an off-angle burst within our galaxy could spell instant destruction, fried electronics, and massive radiation poisoning. Satellites monitoring cosmic activity have recorded several long-duration gamma-ray bursts, but none directly threatened Earth, yet. Still, the possibility remains that, in the vastness of space, someday, a gamma-ray burst could be aimed directly at us, unleashing a lethal wave of gamma radiation that could eradicate life instantaneously. This fleeting cosmic flash, in all its power, stands as one of the universe's most deadly and awe-inspiring phenomena. The origins of GRBs, collapsars, and mergers. Massive stars live their lives like ticking cosmic bombs, their fates sealed the moment they ignite fusion in their cores. When these celestial giants exhaust their nuclear fuel, their cores collapse under immense gravity, producing what astrophysicists call collapsars. In this process, the star's core shrinks rapidly, forming a black hole or a neutron star, while the outer layers are violently expelled into space. This sudden implosion unleashes an extraordinary burst of gamma rays, the most energetic form of electromagnetic radiation, creating a gamma ray burst (GRB). These events are brief but unimaginably intense, flooding nearby space with lethal radiation that can obliterate life on any planet in the vicinity. Meanwhile, on the cosmic scale, some GRBs are born from the violent mergers of compact objects, neutron stars, or black holes. Over eons, these dense remnants orbit each other in a deadly dance, spiraling closer through the emission of gravitational waves. When they finally collide, the energy released dwarfs entire galaxies, forging heavy elements and producing twin jets of gamma rays streaking through space at nearly the speed of light. Such mergers are not only sources of violent radiation, but also the only confirmed birthplace of heavy elements like gold and platinum. Yet, it's this same violent merger process that can send a deadly gamma ray blast coursing through the universe, threatening worlds and even entire civilizations in the potential local neighborhood. The physics behind collapsars and mergers underscores an unyielding truth. The universe punishes with relentless certitude. The raw power of these cosmic events is almost unfathomable, with energy outputs rivaling what our sun would emit over billions of years concentrated into mere seconds. A nearby GRB from a collapsar could effectively sterilize a planet's surface, stripping away its atmosphere and boiling its oceans with gamma radiation. The very fabric of life, fragile and fleeting, stands on the edge of annihilation during these cosmic catastrophes. Given the vast distances in space, the threat is minimal. Yet the potential for a sudden, destructive burst from a nearby galaxy looms as a stark reminder that the universe's violence is both awe-inspiring and terrifying. In the grand scheme, these cataclysmic origins connect us to the universe's more violent and unpredictable nature. They remind us that at any moment, a star's death or a catastrophic merger in a distant galaxy could send a lethal gamma ray burst hurtling across space, with the capacity to wipe out entire planets in an instant. The forces that forge these bursts are rooted deep within the core of exploding stars or the merger of dense remnants. Events so powerful they reshape the cosmic landscape, yet so fleeting they often escape detection until after the fact. In this cosmic ballet of death and rebirth, humanity remains unprotected, floating in a universe where the most violent acts are but a blink away from unleashing unimaginable destruction. Frequency of gamma ray bursts in the universe. Gamma ray bursts are among the most energetic and mysterious phenomena in the cosmos, yet they are astonishingly rare on a galactic scale. Occurring roughly once or twice per day somewhere in the observable universe, these flashes of gamma radiation are like cosmic lightning bolts, bursting forth with a ferocious intensity that briefly outshines entire galaxies. Despite their rarity in a single galaxy, the vastness of the universe means that when considering billions of galaxies far beyond our Milky Way, the number of these catastrophic events adds up significantly. The frequency becomes a cosmic roulette wheel, with each spin potentially unleashing a deadly gamma ray beam toward us. Within the grand tapestry of space, gamma ray bursts tend to happen in specific environments. Long-duration GRBs are most often associated with massive, collapsing stars, hypernovae, that burn through their fuel quickly and collapse into black holes, unleashing jets of gamma rays. Short-duration bursts, on the other hand, are linked to the violent mergers of neutron stars. Although these events are sporadic, their occurrence rate in the universe is enough to keep astrophysicists on edge. The sheer scale of the universe means even rare, cataclysmic explosions happen with a frequency that's statistically significant over cosmic time. One burst every few days in the observable universe might seem infrequent locally, but when scaled up across billions of galaxies, they become a persistent threat lurking beyond the veil. The real danger lies in the directional nature of gamma-ray bursts. These flashes emit highly collimated jets, like cosmic laser beams piercing through interstellar clouds, focused, precise, and devastating if aimed our way. The likelihood of a burst jet actually hitting Earth, however, is incredibly slim. Still, given the number of galaxies hosting such explosive events, the odds aren't negligible. Models suggest that, on average, Earth might face such a lethal event once every few 100 million years. A blink of an eye in cosmic terms, but enough to potentially wipe out all complex life. The frequency isn't constant. It's a stochastic dance of chance, with long periods of silence interrupted by sudden, monstrous outbursts that could erase us instantly. Science indicates that while gamma-ray bursts are rare on a human timescale, their frequency in the universe isn't negligible when viewed through the lens of cosmic history. Each burst acts like a cosmic lightning strike, rare but profoundly impactful. The sheer scale of the universe ensures that, somewhere out there, a gamma-ray burst is often unfolding, a deadly signal traveling at the speed of light. When one happens to be pointed directly at our solar system, there's no shield against its destructive power. The rarity across any single galaxy turns into an almost inevitable hazard over eons, an ongoing cosmic threat that reminds us how fragile and fleeting our existence is amid the vast, violent universe. The theoretical impact on Earth. A gamma-ray burst intense enough to strike Earth directly would unleash chaos on an unimaginable scale. These cosmic explosions, producing more energy in a few seconds than our Sun will emit over its entire lifetime, are typically associated with the collapse of massive stars or neutron star collisions. If one were directed precisely at our planet, the immediate inundation of gamma radiation would incinerate the upper atmosphere in moments. The atmosphere acts as a shield, absorbing dangerous particles and radiation, but a nearby burst would utterly overwhelm this buffer. The result? A sudden, overwhelming wave of ionizing radiation rippling through our protective layer, stripping away the ozone layer in an instant, leaving Earth exposed to the full fury of solar and cosmic radiation. The consequences would cascade into a chain of global catastrophe. With the ozone layer obliterated, ultraviolet radiation from the sun would flood Earth's surface, scorching living tissue worldwide. Plants, unable to cope with the sudden barrage, would rapidly die off, collapsing the foundation of the food chain. In a matter of weeks, ecosystems would unravel, leaving only barren wastelands behind. The atmospheric upheaval caused by such a burst might also trigger powerful electromagnetic pulses, frying satellites and electrical grids. Communications would crumble, power plants would go dark, and humanity would be plunged into an electromagnetic blackout, unable to coordinate or escape the chaos unfolding. Historical near misses and clues. In the vast, dark tapestry of the universe, gamma-ray bursts, GRBs, are the most energetic explosions known to humankind, releasing in mere seconds more energy than our sun will emit over its entire lifetime. The terrifying part isn't just their power, but their unpredictability. Hidden within their cosmic origins are subtle clues, faint whispers of past, near misses that echo across space and time. These clues serve as ghostly fingerprints, evidence that Earth has flirted with catastrophe more than once, and that the threat from these cosmic tempests is not hypothetical, but a lurking possibility in the fabric of the universe. Some of these clues are embedded in the distribution of long-soft GRBs, which are believed to originate from collapsing massive stars collapsing into black holes. Their bursts pierce through the universe, but sometimes seem to track certain regions with mysterious frequency, hinting at origins nearby or within our galactic neighborhood. Though direct evidence is scarce, scientists have identified patterns suggesting that extremely powerful GRBs have occurred in or near our galaxy, with the potential to gatecrash our cosmic neighborhood. These are not distant, dying stars far in the void. They are potential threats from sources that, under the right conditions, could emit a beam of lethal gamma radiation directly toward Earth. Certain stars that could produce such bursts are seemingly dormant, waiting silently for a cosmic trigger. The sudden collapse of a supermassive star into a black hole, for example, could unleash a colossally focused jet of gamma rays aimed precisely at us. Evidence of such noble celestial bodies exists in our galaxy. Nestled in the chaotic arms of the Milky Way, their silent potential for destruction stored like explosive tinder. The fact that our planet orbits amidst such volatile cosmic artillery raises unsettling questions. How close have these cataclysmic events come to us? The problem isn't just the bursts themselves, but the precursors, sketches, faint gamma-ray signals, or unusual cosmic rays that might serve as early warning signs if we knew where and how to look. The history of near misses is written in the high-energy particles and faint gamma-ray signals that sporadically sweep across Earth's atmosphere. These phenomena, often dismissed as cosmic noise or background radiation, might be remnants of past, aborted gamma-ray events whose beams graze the edges of our solar system. Some researchers have suggested that certain mass extinction events recorded in Earth's geological layers coincide with increased cosmic ray activity, possibly tied to solar system encounters with dormant or dying gamma-ray sources. While nothing definitive ties these clues directly to imminent danger, the pattern of these signals fuels a quiet but growing alarm. Earth's history may be riddled with cosmic brushes with death, close enough to leave scars, but distant enough to avoid full annihilation. Yet the next encounter could be different, a direct, unambiguous gamma-ray blast capable of sterilizing life in an instant. The deadly weapon in cosmic terms. Gamma-ray bursts, or GRBs, are among the universe's most ferocious phenomena, a flash of cosmic devastation that can outshine entire galaxies within seconds. These bursts unleash torrents of gamma rays, the most energetic form of electromagnetic radiation known. To put it into perspective, in that fleeting moment, a GRB can produce as much energy as the sun will emit over its entire lifetime, concentrated into just a few seconds. Such a release of energy strips through space like a sword of pure destruction, capable of altering or annihilating every atom in its path. What makes these cosmic weapons particularly terrifying is their pinpoint precision combined with their staggering power. They are believed to originate from either the collapse of massive stars into black holes or the collision of neutron stars, cataclysmic events that send out narrowly focused jets of gamma radiation at close to the speed of light. If Earth were directly in the path of one of these jets, it would be like a flash of pure annihilation. The gamma rays would interact with the atmosphere, creating a cascade of secondary particles and ionizing radiation that would obliterate the fragile layers of life's defenses. It's not just a matter of burning or frying. It's an instant wipeout, resetting entire ecosystems in a cosmic heartbeat. The scale of potential devastation becomes even more startling when you consider the proximity factors. GRBs can occur billions of light years away, yet their destructive beams are so focused that a relatively distant event could still pose a threat. The Milky Way's own center harbors a supermassive black hole, and occasionally, the galaxy produces its own gamma-ray flares. But a true threat would be a long gamma-ray burst originating from a nearby galaxy, possibly just hundreds of millions of light-years away, a relatively close neighbor on cosmic scales. Such a burst could strip away the ozone layer, causing mass extinctions by allowing lethal ultraviolet radiation to reach the Earth's surface, effectively pressing the reset button on life. Some scientists worry about the frequency and distribution of these cosmic cataclysms. While GRBs are rare on human timescales, perhaps once every few million years, when they do occur nearby, the consequences are devastating beyond measure. The lethal nature of these bursts is compounded by their ability to be invisible until they ignite, when suddenly, the universe's purest weapon is unleashed with no warning. To stare into the cosmos and recognize that such an asteroid-like threat exists, silently waiting to ignite, is to confront the raw, unyielding power of a universe that plays favorites with annihilation nearly as easily as with creation. Potential for Earth's immediate destruction. A gamma-ray burst, GRB, in essence, is a cosmic shotgun blast of staggering energy, capable of dwarfing entire galaxies in terms of raw power. If one were directed precisely at Earth, it would unleash a flood of gamma radiation that would cascade across the planet like a celestial siege weapon. This intense blast, lasting just seconds to minutes, would deliver a dose of radiation equivalent to billions of nuclear bombs, capable of vaporizing the upper atmosphere in an instant. Such a burst could instantly strip Earth's protective ozone layer, leaving the entire biosphere exposed to lethal solar and cosmic radiation. The immediate aftermath would be catastrophic, with the greenhouse effect plummeting as the atmosphere disintegrates, rendering surface life extinct within moments. The energetic photons emitted during a GRB are not mere light. They are ionizing radiation with enough force to shatter chemical bonds. In the blink of an eye, the radiation would strip electrons from atoms in the upper atmosphere, igniting a chain reaction of atmospheric destruction. The sudden energy influx could ignite the nitrogen and oxygen molecules, creating a cascade of nitrogen oxides that would deplete remaining ozone layers in mere seconds. This process would turn the atmosphere into a toxic, electrically charged haze, a literal cosmic furnace igniting the sky itself. The direct effect on life would be swift. All unprotected life on the surface would be annihilated almost instantaneously, while satellites and space stations would be vaporized by the overwhelming photon bombardment. Beyond the initial explosion, the secondary effects would be equally devastating. The intense radiation could trigger massive wildfires globally, as the Earth's surface becomes bathed in gamma rays and intense heat. The energy deposited into the atmosphere would generate violent electrical storms, creating lightning that would ignite fires across continents. The sudden ionization could also spark a worldwide electromagnetic pulse, fry electronic systems, and plunge civilization into chaos. If the burst is pointed such that Earth becomes the target, the planet's magnetic defenses would be overwhelmed, leaving the planet exposed to further cosmic radiation influxes. The rapid destruction of the delicate balance that sustains life would transform Earth into a barren, irradiated wasteland in a matter of moments. The threat is not purely hypothetical. The universe has seen gamma-ray bursts of comparable magnitude. The problem lies in their unpredictable nature. We cannot telescopically predict where the next burst will originate or when it might happen. If the beam directly hits Earth, there's no salvation. With no warning system capable of alerting us sufficiently in advance, humanity stands vulnerable to an instantaneous cosmic annihilation. The universe may be a serene and majestic realm, but within its depths lurk these violent explosions capable of erasing entire worlds in a flash, striking fear into the very notion of cosmic stability. Earth, tiny in the grand scale, would become a flickering point of light, snuffed out by the universe's own fiery fury. Effects on the atmosphere and biosphere. A gamma-ray burst flashes across the universe like a cosmic lightning strike, a concentrated beam of energy that can dwarf entire galaxies in its raw power. When directed toward Earth, this violent eruption doesn't just flicker out into silence. It unleashes a barrage of high-energy photons capable of punching through our atmosphere with catastrophic consequences. The immediate interaction begins with ionization, stripping electrons from nitrogen and oxygen molecules, our atmosphere's backbone, transforming the delicate layers that shield life into a fractured, unstable barrier. This sudden surge of ionizing radiation effectively bleeds into the ozone layer, causing rapid and widespread destruction. As the burst gamma rays pierce through this crucial protective shield, chemical reactions ignite that drastically thin the ozone layer. The aftermath resembles a cosmic wildfire tearing through the delicate balance that sustains life on Earth's surface. Ultraviolet radiation from the sun floods in unfiltered, battering living organisms with lethal doses. Plant life, upon which the food chain depends, faces extermination. Photosynthesis hampers as DNA molecules suffer relentless damage. Without the ozone's integrity, the biosphere morphs into an unrecognizable wasteland where mutations run rampant and many species are wiped out instantaneously or doomed to extinction. The atmosphere itself becomes a breeding ground for dangerous chemical reactions. Nitrogen oxides, produced in abundance during the burst, act like a toxic fog, trapping heat and causing intense acid rain that devastates ecosystems. Simultaneously, the influx of energetic particles can spark atmospheric chemical cascades, creating compounds that further deplete the ozone and release greenhouse gases at lethal levels. These transformations aren't just local. They ripple globally, disrupting climate patterns and leading to a collapse of the delicate equilibrium that sustains life over centuries. It's as if a cosmic doomsday machine has turned Earth into a hostile, radioactive wasteland in moments. The biosphere faces nearly instantaneous annihilation, with most surface life forms unable to withstand the intense radiation and atmospheric upheaval. While deep-sea creatures and subterranean organisms may survive the onslaught, the surface-placed ecosystems, forests, deserts, even microbial communities, vanish in a flash of destructive energy. The cascade of atmospheric effects following a gamma-ray burst guarantees a death knell for complex life, stripping Earth of its vitality in what feels like seconds on a cosmic scale. The very fabric of Earth's atmospheric shield, once a buffer against the chaos of space, becomes a battleground that leaves behind a scarred, lifeless planet, a haunting testament to the destructive fury of the universe. Signs of past gamma-ray encounters. Beneath the quiet veneer of our planet's surface, traces from ancient cosmic storms whisper stories of encounters beyond our immediate perception. When a gamma-ray burst sweeps across space, it unleashes an extraordinary torrent of high-energy photons capable of punching straight through stellar dust and planetary atmospheres, leaving behind subtle yet telling scars. Evidence of these past assaults can be encoded in isotopic anomalies, rare cosmic fingerprints woven into the fabric of Earth's geological history. For example, an excess of certain isotopes like iron-60, which originates from supernovae and gamma-ray sources, has been found embedded deep within Earth's crust and ocean sediments. These isotopes don't occur naturally at high concentrations under normal conditions, making their presence a silent testament to catastrophic radiation events long ago. Cosmic rays generated during gamma-ray bursts also leave indelible marks on planetary atmospheres. When these intense bursts occur, they can cause a cascade of nuclear reactions within atmospheric molecules, producing nitrates and other reactive compounds. In layered ice cores from polar regions, scientists first detected spikes in nitrate levels that correlated loosely with periods of astrophysical disturbance. These nitrate anomalies are like cosmic graffiti, signs that Earth's shield was pierced by high-energy particles, clues stitched into ice layers that record every cosmic upheaval. They serve as a celestial diary, chronicling moments when solar and galactic radiation environments experience profound upheaval, possibly from nearby gamma-ray bursts. On a longer timescale, biological signatures also betray evidence of past gamma-ray onslaughts. Extinction events, mass die-offs, and sudden evolutionary shifts sometimes align with hypothesized gamma-ray episodes. While difficult to tie directly to gamma-ray bursts, some paleontologists suggest that elevated mutation rates and sudden ecological collapses could be linked to radiation doses delivered during such cosmic assaults. These radiation events could have sterilized vast regions, forcing life into isolated pockets or triggering catastrophic genetic mutations. The genetic scars and sudden shifts in ancient biota serve as the biological fingerprints of cosmic violence, reminders etched into the very fabric of life's history on Earth. All these signs, rare isotopic anomalies, atmospheric chemical bursts, biological upheavals, are relics of a dynamic universe capable of unleashing destructive gamma-ray bursts with the power to snuff out life in a heartbeat. Their existence underscores just how fragile and exposed our cosmic address really is. These traces remind us that, somewhere in the vast stretch of space, a flash distant yet deadly could wipe the slate clean in an instant, erasing ecosystems, memories, and entire civilizations, leaving behind only ghostly echoes of cosmic fury in our planet's deepest layers. Preparations and monitoring systems. Beneath the silent darkness of space, sensors and observatories stand vigil like cosmic sentinels, meticulously calibrated to detect the faint whispers of gamma-ray bursts far beyond our galaxy. These cataclysmic explosions, capable of releasing more energy in seconds than the sun will emit in its entire lifetime, pose an existential threat with their incomprehensible power. To stand a chance against such rare but devastating phenomena, a network of monitoring systems sprawls across continents. Space-based telescopes like the Fermi Gamma-Ray Space Telescope and Swift Satellite constantly watch for sudden spikes in gamma radiation. Their automated alerts can ping through the digital ether within moments, narrowing down the source, calculating intensity, and assessing potential destructive pathways. These instruments are bolstered by an intricately woven web of terrestrial detection facilities, designed not just to spot gamma-ray bursts in real time, but to analyze their celestial trajectories with pinpoint accuracy. Advanced algorithms sift through torrents of data, filtering out false alarms and honing in on genuine threats. When a burst is detected, predictive models kick into gear. They estimate the burst's energy dispersion, jet orientations, and potential impact zones. This rapid, layered analysis is vital. Even a few seconds of warning could be a life-saving window. In some cases, alerts are disseminated to space agencies and scientific institutions worldwide, initiating emergency protocols that, while not always enough to prevent disaster, may help mitigate secondary effects like intense radiation storms or satellite disruptions. Designing these systems comes with staggering challenges. Gamma-ray bursts are unpredictable by nature, often occurring in distant corners of the cosmos with no warning sign beforehand. To improve our readiness, efforts are underway to develop more sensitive detectors that can distinguish faint, early signatures of a burst, possibly providing an even shorter response time. Proposals include deploying satellite constellations in higher orbits, offering a broader observational scope. Ground-based telescopes, equipped with rapid response capabilities, scan the night sky for afterglow emissions that might hint at an imminent threat. Yet, despite technological advances, the void of certainty remains. Gamma-ray bursts are cosmic beasts hidden in the shadows, waiting to unleash their fury when least expected. Amid all this, international cooperation plays a pivotal role. Agencies like NASA, ESA, and institutions across the globe share data, coordinating alerts and research to refine our predictive models. The goal extends beyond detection. It's about having a layered, resilient defense structure that can respond even when faced with the universe's most unpredictable outbursts. By continuously upgrading these systems, running simulations, and pushing observational frontiers, humanity seeks not just to watch the cosmos dance, but to understand and, perhaps one day, anticipate the step that could wipe out life on Earth in a heartbeat, like a cosmic lightning strike from an unseen thundercloud. The search for a cosmic early warning. In the vast darkness of space, gamma-ray bursts, GRBs, are like cosmic detonations, blinding flashes of energy that release more power in seconds than the sun will emit over its entire lifetime. These phenomena originate from catastrophic events, such as collapsing massive stars or merging neutron stars, unleashing gamma radiation so intense that it can traverse billions of light years, transmitting a warning from the universe's most violent corners. Yet, despite their ferocity, our knowledge about predicting or detecting these bursts before they happen remains tantalizingly limited. Once they ignite, their lethal potential becomes glaringly apparent. The gamma rays can strip away Earth's protective ozone layer, drown the atmosphere in deadly radiation, and obliterate the fragile balance that sustains life. The real problem lies in the unpredictability. Unlike solar flares, which can sometimes be foreseen by monitoring the sun's activity, gamma-ray bursts come as cosmic surprises, harbingers of destruction from regions we can hardly observe in advance. The universe doesn't send us a heads-up or a warning signal. No cosmic alarm clock ticks to indicate an imminent cataclysm. Instead, astronomers rely on an array of sensors scanning the sky continuously, like sentinels on a cosmic watchtower, hoping to catch the faint echoes or precursors of these explosions. Some theories suggest that certain types of precursor signals, such as specific gravitational waves or 10th-ray emissions, could herald an impending burst, but these signals are faint and often buried in background noise. The challenge is developing instruments sensitive enough to detect innocent-appearing signs that are actually cosmic death cries in disguise. If the next gamma-ray burst aligns so that Earth is in its firing line, the consequences could be instantaneous and devastating. The gamma rays would flood our atmosphere, igniting chemical reactions that could rapidly deplete the ozone layer, our shield against the sun's harmful ultraviolet radiation. Without this barrier, life would be exposed to lethal radiation levels, with the potential to wipe out entire ecosystems in a matter of hours. The burst's intensity could also trigger electromagnetic disturbances that fry satellites, disable communication systems, and plunge humanity into chaos. The notion that the universe could deliver such a lethal strike without warning looms as a cosmic nightmare, an invisible sword hanging over our fragile existence. Yet, some scientists persist in the hope that a true early warning system may someday be within reach, an array of detectors tuned not just to catch the aftermath, but to sense subtle signs igniting in the fabric of space-time. Advances in gravitational wave astronomy, with instruments like LIGO and Virgo, lend a flicker of hope, as merging neutron stars could produce telltale ripples seconds before unleashing gamma radiation. Such signals could act as a cosmic siren, providing precious moments to activate protective measures or evacuate vulnerable regions. Still, the scale of this challenge remains staggering. To develop a system capable of predicting a burst from the depths of space with enough time for a meaningful response would require a leap in technology, and perhaps a dose of cosmic luck. Until then, humanity remains vulnerable, staring into an abyss where a single, silent cosmic gunshot could erase all life in an instant. The future of humanity in a gamma-ray era. A gamma-ray burst, GRB, isn't just a colossal burst of radiation. It's a cosmic flare that can outshine entire galaxies in an instant, releasing as much energy in seconds as our sun will produce over its 10-billion-year lifespan. These bursts originate from cataclysmic events like collapsing massive stars or neutron-star mergers, unleashing torrents of gamma radiation traveling across the universe at the speed of light. When one of these colossal explosions points directly toward Earth, the consequences could be apocalyptic, a death ray from the depths of space capable of sterilizing our planet in a heartbeat. The danger lies in the intense power of gamma rays to strip away Earth's atmosphere, especially the ozone layer that shields us from harmful solar and cosmic radiation. A direct hit would bombard our atmosphere with lethal doses, incinerating the fragile balance that sustains life. The initial gamma-ray flash, lasting mere seconds or minutes, could cause irreversible damage, knocking out satellite communications, disrupting global climate systems, and obliterating the DNA integrity of living organisms in the process. The aftermath might see the sky turn a lethal pallid glow, while the surface below becomes a barren wasteland illuminated by cosmic rays in what can only be described as a new dark age. Despite tremendous advancements in astrophysics, the sheer unpredictability and rarity of nearby gamma-ray bursts make them a looming threat shrouded in cosmic uncertainty. Unlike asteroids or supervolcanoes, which we can track or study with some precedent, GRBs strike abruptly, without warning, severing our connection to the cosmic ballet with deadly finality. They are like silent cosmic parasites, lurking at the edge of observable space, waiting for their moment, their flash of destruction capable of rewriting the entire narrative of life on Earth in an instant. The chances of one hitting directly are small, but statistically significant enough that humankind must remain vigilant in our understanding of these celestial death rays. In the grand cosmic scale, humanity exists on a fragile, pulsating thread woven into the fabric of an unpredictable universe. As we venture further into space, sending probes, colonizing moons, contemplating Mars, we brush against the horror of cosmic-scale threats that could erase us as quickly as a flicker of gamma radiation. There's an eerie, unavoidable truth. Our survival depends on managing the unknown, on understanding the universe's lethal potential, before one unforgiving burst from the dark can extinguish all the hope and ambition we've built. Gamma-ray bursts serve as haunting reminders that in the vast, indifferent cosmos, our existence is ultimately fragile, an awe-inspiring thread hanging over an endless abyss. As we peer into the infinite void, the danger of the next gamma-ray burst looming like a cosmic thunderclap echoes a haunting reminder. Our fragile existence hangs in a delicate balance, threatened by forces beyond our understanding. These bursts, capable of unleashing destruction on a scale that makes our most catastrophic fears seem trivial, could erode entire planets in a blink, removing us from the cosmic stage as swiftly as a flickering star vanishes into darkness. Now, first ask you, how small our place in this vast universe truly is, and how vital is that we stay vigilant, curious, and prepared for what cosmic mysteries might send shockwaves through our existence. Stay with us as we delve deeper into these celestial phenomena, what they mean for humanity, and how we might one day coexist alongside such titanic forces. The universe is an awe-inspiring frontier, but also a stark reminder of our humble place within it. Keep watching, stay curious, and together we'll explore what lies beyond the edges of what we can see. Because the next cosmic catastrophe might be just around the corner, lurking in the shadows of the universe's grand design. The future's secrets are waiting, and the story of our survival might depend on understanding the stars that could one day wipe us out in an instant.